Welcome to the Consulting Specifying Engineer webcast, Understand the Benefits of a Fixed versus Withdrawable Vacuum Circuit Breaker. I'm your moderator, Jack Smith, and I'm happy to join you today on behalf of Consulting Specifying Engineer and CFE Media. Here are some tips to enable you to get the most from today's webcast. If you are experiencing issues with your slides or your audio, refresh your browser or click Refresh Media button directly under the presenter's headshot. You can control the volume settings of this webcast by adjusting the volume on your computer. And if you're having technical problems with audio or the slide presentation, click the question mark at the top right corner of your screen to bring up a list of system checks to try before contacting an online technician. But if you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answered Question box on your screen, and type questions for our speaker in the Ask a Question box on the left side of your screen, and the live Q&A session will begin immediately after the presentation concludes. Today's webcast is being recorded, and you will receive an email within a week with the link to the on-demand event. To download a certificate of completion, use Event Resources on the left side of your screen. You can download the certificate of completion at any time until the conclusion of the webcast. The link will break when the webcast signs off, but the certificate of completion will be available with the on-demand version of this webcast. Now we will hear from the sponsor of today's webcast, Schneider Electric. At the conclusion of the video, you may experience a few seconds of silence to compensate for various internet connection speeds. Please stay tuned after the video for today's presentation.
For more than 100 years, Schneider Electric has been an industry pioneer of market-leading solutions. As the engineering landscape rapidly changes, no one feels the impacts of the mounting challenges like consulting engineers. We understand these challenges. We face and solve them with you every day. Projects are becoming more complex, faster moving, and the connected world demands immediate answers while margins grow tighter. As an expert in your own right, we're set on making sure that you're equally matched in the manufacturing company you turn to, which is why we're launching PROficient for Consulting Engineers, a suite of services and tools that gives you unparalleled control from design to implementation, solidifying a real connection between highly qualified professionals. PROficient is built on a foundation of E2E, or expert to expert. Through innovative technology, responsiveness, and industry-leading BIM advancements, PROficient is tailored for you. All backed by market-proven Square D and Schneider Electric products with matchless service and support, we're delivering expertise that enables you to excel. You spoke, we listened. PROficient for Consulting Engineers. Expert to expert.
If you are interested in signing up for the Professional Engineering Portal, visit www.schneider-electric.us/consulting-engineers to register. I'm happy to introduce today's distinguished presenter, Sherry Collins. Sherry is the Senior Offer Management Specialist at Schneider Electric. She's a resident of Nashville, Tennessee, by way of Detroit. She has a Bachelor of Science degree in Computer Engineering and a Master of Science in Electrical Engineering from the University of Tennessee in Knoxville. Sherry has more than 8 years of experience in the medium voltage switchgear industry and brings an additional 2.5 years of experience as an end user customer of Square D. She has worked for Square D, Schneider Electric as an application engineer for more than 5 years, designing metal clad equipment, and now is in product marketing as the product manager for the metal enclosed product line. Again, Sherry Rollins is our speaker today, but also joining us for the live question and answer portion at the end of the prepared presentation, James Stacy, and he's the Director of Medium Voltage Offer Strategy, the U.S. Energy Business at Schneider Electric. Thank you both for your time and your expertise. Sherry Rollins, let's get started.
Hello to everyone, and thank you for joining today's webcast. Again, my name is Sherry Rollins, and I am more than happy and honored to be presenting the information that you will see today. So just wanted to state that the information presented in this presentation is going to be geared more towards basic concept. It's going to be for basic and intermediate applications, so you will not see any advanced type of information on this presentation, so I just wanted to make you aware of that. So today's learning objectives, we will of course be talking about fixed versus withdrawable style switchgear. We will try to understand the operation and maintenance that both pieces of switchgear will entail. And then we'll talk a little bit about application requirements that will help you to identify which switchgear will be the best that you will need for your applications. So just a brief fun fact here I included. So Sir Charles Parsons was the first person who actually invented the steam turbine. In the past, steam was the primary source for using in power substations. Nikola Tesla was the inventor of the AC motor, and he was actually commissioned by Westinghouse back in 1983 to help design the first power system for the Niagara Falls Power Company. That took about 2 years to design, so he was very influential in the startup and build of using switchgear in power facilities. The knife switch design was originally commissioned as the first primary way of disconnecting power coming into facilities. The image that you see on the right of your screen shows what old type of air switchgear looked like. So it was an open air switchgear, that's what it was traditionally called. It didn't have any barriers around it. There were metal partitions in the front that you could see through, and anyone was able to access the equipment. And traditionally, as you see on the top of that image, you can see how the power lines were ran in the facility, and there were no barriers to stop anyone from pretty much accessing that equipment. The knife switch design was unique in that at first they were mounted on wooden plaques, and then they switched them to slate and marble type of backings. So just some information on the switchgear evolution. In the 1930s through the 1940s, we started off with air-insulated type of switchgear. That was the picture that I showed before with the open switchgear. Those were air type of circuit breakers. With the need for more protection, it was noted that people were becoming injured. They were having more incidents occur within their facilities. So the need to have metal partitions or metal barriers built around the switchgear occurred. So in the 1950s to the 1980s, we saw an advancement in technology to where air-insulated switchgear was now being enclosed by metal barriers. You had two different types of switchgear. One was air and one was oil-filled type circuit breakers. Now in the past, they were originally fixed type of breakers, but there was a need to move to a withdrawable style breaker to be able to allow workers to do maintenance on the switchgear and not have it be within such restricted time periods. We also moved in the 1970s through the 1990s to air-insulated switchgear where vacuum-style breakers were being used, and also SF6 was being introduced at this time. In the 1980s, we moved to a gas-insulated type of switchgear, and we also had hybrid type of switchgear that was also created. And then as we advance on from 2010 to now, we have different types of technologies such as solidly insulated type of technology being commissioned, and still advancements in the vacuum-style circuit breakers that we have today. So some characteristics of fixed and withdrawable switchgear we'll go through on this slide. Fixed switchgear is going to be commissioned around the IEEE C37.20.3 standards, and that is a standard that calls for a metal enclosed switchgear. And what's the C37.20.3? It has assemblies containing but not limited to devices such as interrupter switches, selector switches, power fuses, circuit breaker, control instrumentation, metering devices, and protective equipment. What you have for your withdrawable standards is it's going to be still considered metal enclosed because you have the metal barriers around it. But when it comes into terms of our C37.20.3 or the C37.20.2, metal clad can be considered metal enclosed because it still has the metal partitions around it. But metal enclosed switchgear cannot be considered metal clad because metal clad standards call for a withdrawable type of circuit breaker. It is typically going to be compartmentalized, and then you'll have insulated bus, and you'll have the option of having withdrawable VTs and CPTs with this type of switchgear. So traditionally, a metal clad switchgear is going to be withdrawable. It's going to be compartmentalized to isolate all the components such as the instrumentation, your main bus, and both your incoming and your outgoing connections. You'll have grounded metal barriers, and you can also extend the ratings that you'll have for this switchgear. So here, this is just an example of what a fixed vacuum breaker or fixed type of switchgear would entail. For most, you will not be able to remove the breaker. That's where the word fixed comes from. It will ideally be bolted to the main bus. You'll have minimal maintenance because you won't have as many moving parts within the switchgear, hence the reason why it is bolted. You'll have more of a reduced cost because traditionally fixed style breakers will ship within the switchgear. It'll already be housed in the switchgear unit. You won't have the cost associated with the maintenance. And then you'll have a smaller footprint. So that is the reason why switchgear started to evolve from a withdrawable platform to a fixed platform because of the size of withdrawable switchgear was traditionally larger in footprint. Withdrawable characteristics, you'll have a finger cluster type of connection, or you'll have a connection where you can easily separate the actual breaker from the main bus. You'll have increased maintenance, and the reason is because you'll have more components traditionally in your metal-clad type of switchgear or your withdrawable switchgear. So the image in the center shows where you'll have a lot of different moving aspects to your equipment. And the withdrawable need was more so to be able to maintain your switchgear and to do it often. You'll have an increased cost with the switchgear because of your breaker, your finger cluster, MOX and TOX, lubricant, all those different things that go into makeup of your switchgear. And then you'll have a larger footprint. So you'll be able to withdraw that breaker and to roll it on the floor, and then you'll have other accessories that will come along with that switchgear. So the more components you start to add to your switchgear, the more cost that goes into maintaining your actual switchgear. Some different structural characteristics that you'll have. I have a withdrawable type of switchgear on the left, and then I show a fixed circuit breaker type of switchgear on the right. For metal clad, as I stated before, or the withdrawable style, you'll have the insulated main bus. You can see how it is compartmentalized. You will have automatic shutters. That is one of the requirements that come along with a withdrawable type of switchgear. And then you'll see on the top where you'll have your low voltage compartment separated from your breaker compartment. Now, the unique thing about fixed type of switchgear, you can also get those same components, but traditionally you are not limited to the same requirements as withdrawable switchgear. So you have a lot more flexibility when it comes to that design. you have the option of having open type of design. But in this image here, I show where you can actually have compartmentalized options as well. So it's very flexible. So some commonalities between a fixed and withdrawable style breaker is your breaker that you can have within the switchgear. So there are 3 standards that breakers typically follow. It's C3704, C3706, and C3709. So typically you will see a fixed breaker follow those same standards that you'll have for your withdrawable equipment. Your protection options are pretty much the same. It's going to vary based on the size of your equipment or your application need. So that's going to be really independent of the person who needs the equipment. Your VT and your CT and your CPT options, you can have almost the same ratings on either of equipment. And again, that's going to vary based on your application needs. Those are also designed around those same standards within the switchgear. So for fixed switchgear, you're going to see fixed VTs and CPTs, and withdrawable switchgear, you will have the option to have withdrawable VTs and CPTs. So some additional characteristics of fixed switchgear. Typically, you'll see a fixed circuit breaker with an upstream visible disconnect. You will also see a visible disconnect on the actual unit. So there will be some type of window or isolation window where you can actually see a means of make and break in the switchgear. Again, you have the option to have it compartmentalized, but it's not required by the IEEE C37.20.3. You can have an optional grounding switch. Some equipment, it comes as an option. Some, it is standard. You'll have typically fixed-mounted VTs and CPTs, a separate low-voltage compartment, and a smaller footprint. That's what allows it to be narrower. And withdrawable, you'll have a little bit more ease of withdrawing the circuit breaker for maintenance purpose because it'll have wheels on the bottom of the switchgear. You'll have those shutters to close whenever you withdraw the circuit breaker from the actual position. You'll have an option to have electrical racking. With the withdrawable switchgear, you have an option to have a push-button station where you can step back from the switchgear about 25 to 50 feet from the switchgear. You'll have the option to have ground and test devices. That'll be your grounding means for the switchgear. And, of course, it comes with the grounded barriers also within a withdrawable switchgear. It typically requires more space. Traditional middle-class switchgear or even withdrawable switchgear, you will have the need to have a rear aisle and rear and front working space in the front to remove that breaker and to also move it to the side for testing purposes. The unique thing about withdrawable equipment is that you do get the position indicator with the breaker. So it shows you what the breaker state is. It shows you if the breaker is in a test or a withdrawn type of position. Some technical characteristics of withdrawable versus fixed, and this is typical characteristics. These can change based on the manufacturer of the equipment. So for voltage levels, you'll see withdrawable switchgear can go up to 38 kV, and then you see fixed switchgear is up to 27 kV for most manufacturers. The current ratings, you get larger current ratings with your withdrawable switchgear, and that's more because your actual size of the switchgear is larger. So you have between 1,200 amps and 4,000 amps for your withdrawable, and then for your fixed switchgear, you have between 6 and 1,200 amps for your main bus. Your current fault levels varies. You usually typically get more options out of your withdrawable, so it goes up to 63 kA. You'll have more maintenance. That's what I said before with the withdrawable. So you'll have a medium to high type of frequency with your maintenance. And then you'll have a reduced, almost virtually free maintenance to low maintenance with your withdrawable equipment. The size of your withdrawable can range up to 45 inches in width. And then you'll have up to 36 inches in width for your fixed switchgear. And again, that's going to vary by the manufacturer. Your current transformer capacity, typically you can match up to what you can get for your main bus rating. So as you can see from this chart, the current transformer capacity matches the main bus ratings, and your voltage transformer capacity matches what you can have for your voltages incoming to the switchgear. Your protection capability with your withdrawable switchgear, you're looking at more average to advanced type of switching application protection schemes. And then with your fixed switchgear, you're looking at basic, medium applications, overcurrent protections, things like that. So your typical withdrawable would have circuit breakers and contactors that are withdrawable, and then for your fixed switchgear, you can have circuit breakers or you can have a fuse type of application. And then your costs, again, associated, this would be your total cost of ownership. It could be your upfront cost of your withdrawable will typically be higher. Inspection and maintenance that you'll have with either switchgear. So historically, your maintenance on your withdrawable switchgear, of course, will be higher because you'll have more moving components. You'll have to maintain those with the lubricants. You'll have to do some spacing. You have the rear working aisle where you can get into the switchgear. So many manufacturers will have like an annual inspection of every year. They'll maintain their switchgear. Some companies don't have to have that standard based on what type of switchgear that you have in place. So many companies have internal standards based on just equipment maintenance and protection that you'll need for your personnel. You'll want to, of course, abide by the continuing advancement that we have in technology and just the way the advancement of the switchgear is moving. So you always want to update your facility based on where the needs are going for your facility. So some application selection information here. When we consider withdrawable switchgear, you'll want to take into account your high switching applications. And your high switching applications are going to be anything above 10,000 operations. And that's only going to be for like an arc furnace type of application or even capacitor bank switching type of applications. That's where you'll want to look at for if your withdrawable option will be better, anything over 10,000 operations. Most fixed switchgear goes up to 10,000 operations, especially if it has a breaker included versus a fuse. So you'll be able to meet almost any basic rating for any application with a fixed style switchgear. Your space is going to be your advantage when you're looking at application. If you're restricted on your floor plan space, building space, location, things like that, you're going to want to keep the footprint into consideration for what you need. And your fixed switchgear traditionally will be smaller than your withdrawable, so that may be the better option for you. Your end user safety and operational practices. What are your safety concerns for your company, for your people, your personnel who work for you? You want to take those into consideration and look at the different techniques that you get with equipment. Does it come in an arc flash option? Can you do arc flash mitigation? Those different things that you can get with a switchgear. Your protection schemes that you get with it, the size of the relays. Can you have local and remote operation with the equipment? And your shutdown time period that you'll need to consider for your operation. So you have a 2-week time frame where you can maintain the equipment or do your annual inspection on your equipment. And again, some other things to consider is your price for your equipment. You want to look at how much is this going to cost you for your total cost of ownership. You want to consider your installation cost, your cost to maintain the equipment, and any other cost that would go into that. So your key takeaways for the switchgear is to pretty much gauge which one would be the best ideal application for you. You want to ensure people safety, so you want to look at your grounding features that you get within the switchgear. Traditionally, withdrawable switchgear will have grounding, a grounding test unit that you can use in the switchgear. And again, your fixed option will come with the grounding switch that you can have in the switchgear. And a grounding switch is a form of air switch by means of which the circuit or the piece of apparatus may be connected to the ground. The ground and test device is going to be a withdrawable unit that you can have within your switchgear, and that's how you can ground that piece of equipment. We're going to look at local safety and operational practices, and then you're going to look at your intuitive interlocking. With fixed switchgear, you get an interlocking where you can interlock your door to your disconnector, and you have a more visual interlocking sequence that will keep your personnel from accessing live parts of your switchgear. Traditionally, you'll have means for less potential for arcing within your switchgear. So for fixed switchgear, it does offer you that advantage when you're looking at safety. Your footprint Your fixed switchgear is going to allow you a better advantage over footprint. You can fit in more cubicle sizes because they are smaller. You can fit them into more compact, space-reduced, space-limiting buildings and things like that. And then your total cost of ownership. Traditionally, with your fixed switchgear, you would have lower costs associated with the switchgear because you don't have as many moving parts again. With your withdrawable equipment, you have to worry about all of those components that go into the switchgear, the lubricants and the things that you have to maintain with that. With your withdrawable switchgear, you're going to see an increase in your operational expenditures, and with the fixed switchgear, you'll see a reduce in your capital expenditures and your operational expenditures. So overall, your total cost of ownership for owning a fixed switchgear will be reduced. Some upcoming webinars that we have. We will let Jack do this here portion of the presentation.
You should have the registration link to this in the chat window to register for this webcast. It's this expert-to-expert webcast.
So some upcoming 2016 medium voltage webinar series that we have. We have one in April. We have a periscope, metal-clad switchgear, increased protection using vacuum circuit breakers over fuses. And then there is one going to be hosted in June. It's going to be about the HVLCB equipment that was newly launched by Schneider Electric. And it's a hybrid type of metal enclosed switchgear that includes gas and air type of technologies. So tune in for those live broadcasts on Periscope. So we will now take any questions that you have for submitting them. You would type your questions in the Q&A box.
Now our presenters will answer questions from the audience. Type your questions for today's presenters in the Ask a Question box on your screen. We will get to as many questions as time allows. Questions that we do not get to today will be posted online at www.csemag.com with the archived version of the webcast. As a reminder, to download the certificate of completion for today's webcast, please use the event resources on the left side of your screen. So we have a lot of questions coming in today, and we'll get started in just a second, and we'll get to as many as we have time for. So the first question, how does the grounding options for fixed switchgear compare to traditional grounding means for withdrawable switchgear?
Well, excellent question. Hello, everyone. This is James Stacy. Typically, withdrawable switchgear is also coincidentally typically air-insulated switchgear, which could be either metal-clad or metal-enclosed switchgear per the ANSI standards. And really, there's two means of grounding that's typically used in the United States for withdrawable equipment. One that Sherry mentioned was a ground and test device, and what this is a removable element, like the circuit breaker is removable from the switchgear, and you insert this grounding device, and it's a means that one can interact to connect between the cable side or the bus bar main bus side of the switchgear to the ground. So it's a very kind of a manual means, and it's a device you insert in lieu of a circuit breaker. The second method that's typically used in withdrawable switchgear is a very manual process where one puts on their PPE, uses a hot stick and a cable grounding assembly, and one physically connects cable between the bus bars and the ground bus. Obviously, there's some exposure or potential risk with that activity if there is still accidentally energized potential. So that's the practices on the withdrawable switchgear. That's very common. Now, if we look to the fixed mounted switchgear, it's quite quite different in the fact that a big differentiator is the grounding and fixed mounted switchgear. I think Sherry mentioned there is grounding switch options, and if one chooses to use the grounding switch, it's a fault rated device that is mechanically interlocked with the switchgear, so it's intuitive from operations point of view. And since it's a fault-rated grounding switch, the device is rated if someone accidentally does close the switch onto an energized bus. But in any means, this grounding switch does, as the name implies, creates a short circuit between the bus bars of the switchgear and the ground potential, thus ensuring that everything is at ground potential before one gains access to the cable compartment, typically for fixed-mounted switchgear.
That's a good question and a great answer. So next question, is fixed-mounted switchgear applicable to redundant mains?
All right, that's a great question. And I think a lot of these questions come about fixed versus withdrawable, because I would say historically in the United States, withdrawable switchgear is probably more common than fixed. So to answer the question, yes, absolutely. Fixed-mounted switchgear is very applicable to, quite honestly, most applications, except those that have an extreme or abnormal number of switching operations. And I think Sherry mentioned 2 examples of that could be cap switching or arc furnace. So if you're switching multiple times an hour, multiple times a day, and over the life of the switchgear, you do expect to have over 10,000 operations, then typically that's when one would look at withdrawable switchgear, because a breaker would reach end of life and one would simply insert a new breaker or refurbish the breaker very easily. Whereas in fixed-mounted switchgear, that is not the design intent. The design intent for fixed-mounted switchgear is the device has the same number of operations, say 10,000, but it's for applications that's less than 10,000 operations throughout its life. And even though you may have dual mains, even with an automatic transfer system, as long as they're at 10,000 operations or less, fixed-mounted switchgear is a very suitable switchgear design.
Thanks. So next question, how do fixed versus withdrawable breakers compare in terms of cost?
All right, another great question. Now, there are some overwhelming benefits that we heard about for fixed-mounted switchgear, and definitely one of them is the cost. Because fixed-mounted switchgear is optimized, it's optimized in many aspects, we can pass along as a manufacturer those savings to the marketplace. So typically you'll see fixed switchgear at least 15% less expensive than withdrawable switchgear. So it's really a very strong value proposition one should consider.
Okay, next question. Physically, how much smaller is fixed switchgear than the withdrawable type?
Okay, this is a tricky question because obviously it depends on manufacturer to manufacturer, design and innovation to innovation, but I can say for example, in our portfolio, it could be significant. It can be anywhere from 50% to 85% smaller than withdrawable switchgear, and mainly because of 2 reasons. The switchgear itself is smaller, but if you also take advantage of most of these designs as being front access only, you can put the back against the wall, so you're saving that National Electrical Code clear working space, which could be up to 6 feet behind the equipment, completely eliminated. So quite a bit of savings in that respect.
So the answer is it depends.
It's obviously going to depend upon the manufacturer, but like I said, in our portfolio, it's going to be significant, at least 50 to 85% smaller.
I know that Sherry covered this, but one of our attendees would like you to answer which IEEE/ANSI standards apply to fixed and draw-out switchgear. There's a lot of numbers there, so maybe a refresher on that.
No problem. So typically the dominant standards that the industry uses in the United States today to specify medium voltage air-insulated switchgear, which could be fixed or withdrawable, is going to be either the ANSI IEEE metal enclosed standards or the metal clad standards. The metal enclosed switchgear standard is what's called a C3720.03, and the metal clad is an IEEE C3720.02. And the way they differ is pretty drastic. I think Sherry mentioned this, but the metal clad is actually a subset of the metal enclosed. I think I heard her mention that metal clad equals metal enclosed, but just because you're metal enclosed does not mean you equal metal clad. Once you classify or meet to metal clad, you've got to meet very descriptive criteria in that standard, and the standard itself dictates that the removable elements must be withdrawable, like the vacuum circuit breakers, voltage transformers, etc. Standard also has requirements on the thickness of the sheet metal. It has requirements on having the racking mechanisms, the shutters, and many other features that adds cost and complexity to the switchgear design. And that's one of the benefits for one to consider the metal enclosed standard. It's much less prescriptive and gives people or manufacturers, let's say, the ability to innovate and optimize designs for size, cost, and performance.
Thanks. So next question is, again, a little bit of a refresher. Why use draw-out switchgear instead of fixed?
Okay. Just to briefly run through, I think Sherry touched base on quite a few of these, is just at a very high level. One, it's smaller, and I think with these days, with the amount of energy density that we're seeing. So, for example, what I mean by energy density is, let's say you have an existing infrastructure, say a large university that was, say, built 120 years ago. It just didn't have the computer loads, the lighting loads, the HVAC loads that you're seeing today. So as energy density increases, but yet your infrastructure is constrained, there's obviously going to be a natural pressure to have smaller equipment. So size is a big benefit. Less expensive, I think Sherry talked about, or even I answered a question, I think, previously about how fixed-mounted switchgear could potentially be somewhere 15% less expensive than withdrawable switchgear. I think we also saw maybe a message throughout this presentation how there are some improved safety aspects in fixed-mounted switchgear. We talked about having the ability to have integral grounding switches. I think Sherry mentioned potentially having interlock sequence of operations where it ensures you've got a safe operations by whoever is operating or maintaining the switchgear. And fixed enables certain sealed technologies that's just not available in withdrawable switchgear. With withdrawable switchgear, the reason it tends to be air insulated is because you have to get the breaker out. So there's no really way to hermetically seal the breaker and the bus bars to protect them from the environment, or there's no ways to innovate or encapsulate that entire system to make it safe in any other aspect. So there's some limitations once you start requiring withdrawable switchgear. So to summarize, smaller, less expensive, and some improved safety aspects is one reason to consider fixed-mounted switchgear.
Thanks. Now I have a question or two that might not be totally on topic, but I think that you could help the audience understand where to look for this information. What are the GIS trends as compared to AIS solutions?
Yeah, I think we're probably going to have a lot of questions about gas-insulated switchgear, and that's going to be a kind of a separate presentation upon itself. So we'll entertain those questions, but not today, because I really want to stay focused on the fixed versus withdrawable. But feel free to please submit those questions, and I think there's probably going to even be a future webcast that would address those specific questions. And similarly, anything around arc flash specifically. There's so many arc flash or incident energy reduction methods available in the marketplace today that's another subject upon itself that we would like to defer to give its own proper priority in a separate presentation.
Another good answer. Next question, can you use SF6 switchgear indoors?
Yeah, absolutely. So, there's a lot of questions around SF6 that we see. And just to recap, SF6 is colorless, it's odorless, it's non-flammable, non-toxic, and chemically stable. So, matter of fact, if you was to go on Google or your favorite internet search engine, you could find videos of Big Bang Theory, the TV show. You could see the Mythbusters, and you can even find on Kelly Ripa on her show 3 or 4 videos where people actually are inhaling SF6 gas and speaking funny. You know, so there's a lot of misconceptions in the market about it. But quite honestly, the main impact with SF6 is if it does escape into the environment, it does have a greenhouse gas effect. So the whole intent is to prevent it from leaking into the environment. And with our solutions, and probably most other solutions, they're hermetically sealed and would never leak into the environment. And at Inner Life, there is reclamation services available to salvage that chemical from the switchgear.
Next question. I'm thinking this was probably covered, but remind us, what is the difference between metal-clad and metal-enclosed?
Yeah, I think I've kind of addressed that. I talked about the 2 different standards, and I talked about how the metal-clad was very prescriptive, and it had very unique requirements. That's one reason why you'll see from manufacturer to manufacturer, most people's metal-clad look very similar, because that standard really dictates, and it's just high level, it's basically requires the removable breaker from the switchgear. And the standard is not a bad standard, but it was designed back in the day, as Sherry talked about, the evolution of switchgear. You know, older technology of circuit breakers, well before vacuum, such as air and oil, required a lot of maintenance. But as we've migrated to vacuum circuit breakers, and even with today's vacuum circuit breakers, there's really no real service needed on the medium voltage or the vacuum circuit breaker part of the vacuum bottles. Where you see the maintenance needed on switchgear tends to be the trip coils, closed coils, and the motor operator. And in fixed-mounted switchgear, what you'll find is all those serviceable items are on the front of the equipment. So really there's no reason with newer technology to remove the vacuum circuit breaker like there used to be.
Thanks. Now the next question talks about access. Do we need back access or side access for withdrawable units?
Well, there's nothing per se that in the standards that requires rear access, but by far the norm in our environment in the United States is if you have withdrawable switchgear, the norm is you'll need rear access. So typically, ANSI withdrawable switchgear is single high or 2 high, and typically you would require rear access. So there's nothing that would prevent one from having a front access only design, but what you'll see in the marketplace is typically withdrawable does require rear access, and the benefit of fixed is not only the equipment is smaller, but it can be front access only. And that's one reason why you see such significant savings in the footprint with fixed-mounted switchgear.
Okay, now this next question goes back to the SF6. Do you see the SF6 becoming more popular and cost-effective for indoor installations in the future? And the second part of this question is, what advantages or disadvantages does SF6 have with fixed versus withdrawable switchgear?
All right.
I can read that again if you need.
Good question. So, let's break that apart a little bit. I think the first point I'd like to make is we're seeing, at least in the United States, more awareness of SF6 switchgear. You know, in the past, if you're in the utility market, you're very familiar with it. It's in your high voltage gear and even your medium voltage gear. But typically in the commercial, industrial United States market, historically air has been the dominant technology. But in the rest of the world, since the 80s or so, they've had the benefit of SF6 switchgear. So what we're seeing is kind of an awareness in the United States, and it is strongly being considered. And really the value proposition of SF6 from an economy and footprint point of view starts to make real sense at 27 kV and above. It just becomes so much more cost effective and so much smaller than typical 38 kV metal-clad switchgear that for 27 and 38 kV applications, one really should consider gas-insulated switchgear. Was there another portion of that question I need to answer?
Yes. What advantages or disadvantages does SF6 have with fixed versus withdrawable switchgear, I guess?
Okay, yeah.
Again, if you use it
yeah,
for both.
excellent. So,
okay.
you know, air-insulated switchgear, as is as it implies. You have to use air as the dielectric. So that's one reason why air-insulated switchgear is so large. Your bus bars, your conductors have to be spaced so there's no arcing between the phases, there's no partial discharge between the phases. And it obviously, since it's open to air, it's not hermetically sealed. That means dust and contaminants can build up in the switchgear, and thus one reason why there's so frequent maintenance needed in air-insulated switchgear. You got to keep it clean and non-oxidized and things of that nature. So a big advantage of gas-insulated switchgear is that it's all hermetically sealed and protected in the gas. So it really helps not only from the environmental point of view and the fact that dust and contaminants cannot build up onto the conductors or on the breaker, but SF6 is a very strong dielectric, so it allows one to have much more compact equipment. So from an environmental point of view and from a compactness point of view, SF6 is really something to consider. Now, how does that relate to fixed versus withdrawable? Well, if your whole system is hermetically sealed, your breaker and your bus bars, it's almost impossible to very difficult to have removable elements like pulling a breaker out. So what you'll see is typically gas-insulated switchgear will be fixed and air-insulated switchgear will be withdrawable, typically.
Again, great answer. The next question, what do you do if a fixed-mounted breaker goes bad? How do you remove it? Do you have to shut down the incoming power in order to de-energize the bus?
Yeah, and I think that's going to be that's an excellent question, by the way, because that's probably one of the primary concerns is people are so used to interacting with withdrawable switchgear and racking that breaker out if there is an issue. But, you know, you really have to look at the failure modes. The failure modes, and by the way, what I'm getting ready to mention is extremely rare. But over the life of the breaker, you could potentially see tripped coils, closed coils, or motors that would need servicing. And what's the big advantage of fixed-mounted switchgear? Every one of those potential modes of failure are completely addressable from the front. So you do not need to remove the breaker. You just have to remove the front cover, and you can service all those items from the front without any removing of any components. That's the first advantage. But let's say in the absolute rare case there is a major catastrophic event. Front accessible switchgear is like any other switchgear. You can remove the cubicle from the lineup. And yes, just like you would have to with withdrawable switchgear, you would have to de-energize the main bus as you would with withdrawable switchgear to replace a cubicle. So from that point of view, it's identical. And from the serviceability, the advantage for fixed-mounted switchgear, as I mentioned, is those serviceable items are available from the front without removing any devices.
So the next question, are fixed breakers UL listed up to 38 kV?
Well, you know, that's going to be a manufacturer-specific question, but I can tell you there are going to be choices in our portfolio that will be UL listed to meet your needs, but it's going to be a manufacturer-dependent question.
Okay, and the next question, why would the protection complexity be different from a fixed to a withdrawable breaker if you use a dedicated relay for protection?
Okay, that's a good point. I think maybe in the presentation it maybe had a connotation that there would be some differences in protection. I think the connotation or the thing we need to convey is what you'll see in fixed-mounted switchgear, because it's smaller, you will have typically less space, because historically air-insulated switchgear has been very large, and real estate hasn't been a premium. You've had all this space to do all these very large protective relays and all these complex electromechanical devices. Well, the good news is we have migrated from electromechanical devices, I should say, in most parts of the country. And with now these new electronic devices are so small, so capable, that it shouldn't be an issue. But I think the point is that fixed-mounted switchgear is smaller, so thus your low-voltage space would be smaller than typical air-insulated switchgear, but not to have a negative connotation to that, it is still sufficient to meet most of the needs by far in the marketplace.
Okay, moving on to the next question. Have you seen medium voltage generator breakers as fixed-mounted breakers?
Yeah, you can see that for sure. Absolutely, is something to consider. It's going to depend on two things. Two things. Mainly is the number of operations you expect in the lifetime, and I think we mentioned that earlier. If you have over 10,000 operations expected over the life of the breaker, one should consider withdrawable. And it doesn't matter if you're fixed or withdrawable. You know, the breaker technology is the same. And if you're going to have 30 to 40,000 operations on the breaker, some generators are very frequently tripped, some are not. It's just really going to depend on the application. So there's nothing about generators per se that would inhibit consideration of a fixed mounted solution versus a withdrawable solution. And the other thing to consider is, do you need that very robust ANSI standard? It's a C3713 or 13A that's specific for generators. Typically, you'll see that specified if you have a very large, very mission-critical generator that has to interrupt, the breaker would have to interrupt a lot of X to R ratio. Without getting into the details, most people do use general-purpose circuit breakers for generator applications. So without getting too specific on this subject, I would say absolutely 90 to 95% of the applications for generators definitely could be considered from as you would with withdrawable.
Hey, the next question, are fixed breakers electrically operated, and do you need a DC battery or DC bus for controlling?
Yeah, so, since they're going to meet the same, ANSI standards, and if you have the UL listings, what you'll see is the control power requirements will be the same. There's nothing about fixed gear versus withdrawable gear that's going to create new control power requirements. So whether you're DC control power with batteries or AC control power provided by the end user somewhere, those would be the same exact criteria. And yes, you can have motor charging in fixed mounted switchgear just like you have motor charging in withdrawable switchgear. There again, I think the main message is most of the features that you'll see on the fixed mounted circuit breakers will be identical to the withdrawable circuit breakers if you look at the circuit breakers themselves. Obviously the big difference is you just physically cannot, it's not intended to be removed on a frequent basis in fixed mounted switchgear, if ever.
Okay, we've got time for a few more questions. So the next one is, do you have any examples where this type of switchgear has been integrated into an existing facility as an upgrade? And I guess how easily is it to retrofit this?
That's a good question. Probably the biggest thing to consider is where your cable entrances are. If your bottom entry, typically in the United States, is pipe or conduit stubbed up in concrete. So I think it's mainly a consider. If your top entry, maybe you have more flexibility because you have overhead cables. But it's not really going to be something that's fixed or withdrawable decision. It's going to be, can the equipment accommodate the existing cable infrastructure? Or if you're connecting to existing medium voltage equipment, can this equipment be directly coupled, or does it require some kind of transition section? And all these can be accommodated, whether you're fixed or withdrawable. So, to me, I don't think it's really a criteria whether you're fixed or withdrawable for this question. It's going to be unique to each application's cabling and what it's connecting to.
Next question: what is the limit on the number of CT sets that could be installed in the fixed switchgear?
Trying to keep this as generic and have an industry discussion on fixed versus withdrawable, it's really going to depend on the manufacturer and their design. But I can tell you, in our portfolio, we can have the same number as you do on withdrawable. It's just really going to depend on your needs. So if you need 4 CTs per breaker, we do have a fixed mounted design that can have 4 CTs per breaker, just like you see on withdrawable. But there's many instances where you don't need that level of complexity, and that's the whole beauty of, if you go fixed mounted switchgear, let's just reconsider everything. Let's reconsider not only the switchgear itself, but let's reconsider having more simple and more cost-effective protection schemes, and it will reduce the complexity in the field too.
Okay, next question. Does fixed design offer ports for infrared scanning of the buses and the breaker?
Well,
IR windows or IR ports.
That's going to be another one of those manufacturer-specific and offer-specific questions. So I can put it this way. Typically, some means will be provided either for a passive infrared viewing window or maybe active technologies. I think that's the big thing today is, one really has to consider when you have infrared viewing windows, you have to hire somebody to go in once every so often and do these scans. And so you don't have that real-time information. But if you had a continuous monitoring system that's trending and looking continuously at the switchgear, and all that information is available over your Ethernet, then that's a strong value proposition. So really, maybe the question should be asked, are there means to measure temperature versus specifying a specific technology such as infrared viewing windows? And the answer is absolutely yes.
Okay, that works. Next question, does the fixed switchgear come as too high construction?
Typically not, because the value proposition around fixed-mounted switchgear is it's simple, it's small, and it's safe. And the fact that once you start doing too high, you're adding a lot of bus complexity, and you're starting to commingle different circuits in the same cubicle. So one advantage of one breaker per cubicle is you have no commingling of circuits, and it's a simpler architecture, simpler design, and allows for cost-effective, smaller footprint switchgear. But there again, that's going to really depend on the manufacturer and the manufacturer-specific offer.
Okay. Looks like we have time for one more question. And this final question is, can you mix fixed, mounted, and withdrawable in the same lineup?
That's an excellent question. I would envision that most of the install base today is going to be withdrawable switchgear, and we at our manufacturer at least envision that yes, one would retrofit applications or rebuild or replacement, that you would potentially put fixed mounted switchgear as the new equipment option to existing infrastructure. So there's no reason why not. And I kind of mentioned this earlier. The criteria one has to consider is your existing cabling infrastructure and the consideration of how you're going to make those medium voltage connections to that existing switchgear. But you're going to have that same criteria whether you're fixed or withdrawable. But yes, there's absolutely no reason why one could not commingle the different architectures if one had the need to, for sure.
Excellent. Excellent answers. And thanks for the great questions. And thanks again to our great speakers. And I also like to extend a special thank you to our sponsor, Schneider Electric, for sponsoring today's event. And our sponsor would like you to make sure to follow them on Periscope at SE Medium Voltage to tune into their live broadcasts. And with that, now that we're just about done, we would like to hear how we did. The exit survey will pop up on the screen as soon as the webcast ends, and please take a moment to complete it because we use this information to improve our webcasts. Finally, on behalf of Consulting Specifying Engineer, Pure Power, and CFE Media, I'd like to thank you for attending. This concludes our webcast. Thank you and goodbye.